In lesson 4.7, we're going to be talking about finding the LCM of two or more numbers. But you're probably thinking, well, what's LCM? We've been talking about the GCF, the greatest common factor, and now we've got another set of letters. Well, the LCM is the least common multiple. And we'll talk about what that is here in 1 second. So, looking at the multiple of a number. Well, a multiple of a number is the product of that number and a non-zero. So any other number besides 0, because anything times 0 would be 0, so the product of a number and a non-zero is a multiple of it. And a common multiple is a number that is a multiple of each of two or more numbers. So we have to have a common multiple, and to have something in common, you have to have multiple things. And then the least common multiple would be the least one of those. So the LCM, the least common multiple that is common to all numbers. So let's take a look at an example. Find the LCM using lists of multiples. So we're finding the multiples of 6 and 9. So we look through and the multiples of 6. So 6 times 1, 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. And 6 times 6 is 36. And we could keep on going, but it's always good to kind of start off with a few and then see if there's anything in the first few that would be the least common multiple. Multiples of 9. 9 times 1, 9. 9 times 2 is 18. 9 times 3 is 27. And 9 times 4 is 36. So our common multiples that we have between the two. Well, I see 18s and I see 36. So our least common multiples, or our list of multiples that each share is 18 and 36, but the least would be 18 because 18 is less than 36. So let's look at the second one here. Now we have prime factorization. We've been working on prime factorization for a little while, but finding the least common multiple using prime factorization of 6, 9, and 15. So prime factorization of 6, we have 2 and 3. For 9, we have 3 and 3. And for 15, we have 3 and 5. So we're going to list those out. So 2 times 3 make up 6. 3 times 3 make up 9. And 3 times 5 make up 15. We see a 2 appear once in 6. 3 appears twice, and that's the most often in 9. And then 15, we see a 5, and a 5 appears once. We don't need to circle that 3 because these 3's pair up, or actually not those 3's, but it'll actually be, we can look at it saying these 3's. Now you're probably thinking, well, why those 3's and why everything else? Well, if we look at this and say 6 is 2 times 3, and 9 would be 3 times 3. I'm lining up my the prime factors, and then 15 we have 3 times, and I'm going to put the 5 way out here. And if I really wanted to, I could put the 3 just so that we keep it all lined up under things. 3 times 5. So from this point, our common factors, I've got 1, 2. So I have that one. My 3's, those are paired, so I have a 3 here. These 3's pair up, and then I've got that 1, 5. So 2 times 3 times 3 times 5, well, that gives us 90. And so the least common multiple of 6, 9, and 15 is 90. Let's try another one. So the multiples defined, you list the multiples to find the least common multiple of 10 and 12. Well, 10, those are just counting by 10. So, and again, 10 times 1, 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, 10 times 5, 50, 10 times 6 is 60. And multiples of 12. 1 times 12 is 12, 2 times 12, 24, 3 times 12 is 36, 4 times 12, 48, 5 times 12, 60, and 7 times 12, 6 times 12 is 72. I had 60 on my mind again, and because that is 60 being our least common multiple, we list it out, and we find that 60 is our least common multiple. Let's try for 7 and 10. So 7, listing those multiples, we could say, well, 7 times 1, 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 35, 42, 49, 56, 63, 70, 77. We can keep on going. And then if we look at our 10, multiples of 10, we have, again, 10, 20, 30, 40, 50, 60, 70, 80, and we can keep on going. But we don't need to, because we have a common multiple right now, and the least one would be 70. So the least common multiple of 7 and 10 would be 70. Alright, now let's take a look at our last check right here. Prime factorization for the least common multiple of 6, 8, and 12. So again, we could list out 6, 8, and 12. So our prime factorization for 6, we have 2 and 3. So 6 is 2 times 3. And for 8, we have 2 and 4. But then 4 can break down to 2 and 2. So we could say this is 2 times, actually, let's write this as 2 times 2 times 2. And then we have for 12, we have 2 and 6. And 6 breaks down to 2 and 3. So we have 2, 2, and 3. So I could say, well, this is 3 times 2 times 2. And I know that I didn't put my 3 in numerical order, but this will work out here in a second. So if I list out and I'm wanting to say, well, what am I multiplying together? Well, the LCM, that is the common factors times all other factors. So our common factors, I have 2, they have those in common. 6 and 12 share a 3 in common. And 8 and 12 share these 2 and these 2's. So I could say 2 times 3 times 2 times 2. Well, 2 times 3 times 2 times 2. Well, 2 times 3 is 6, times 2 times 2. 2 times 2 is 12, times 2, and I get 24. So the least common multiple, the LCM, is 24 for 6, 8, and 12. But we could show you one other way that we could look at this. So I'm going to erase this part right here. And we could think of this in using what is called our Venn diagram method. And the Venn diagram is when you have your circles and you identify what commonalities 2 or more things have. So since I have three things, I'm going to draw three circles and use another color to identify 6, 8, and 12. Well, in our circles, we're going to list out what those what those prime factors are. So for 6 has 2 and 3, but 6 shares 3 with 12. So 6 and 12, it shares a 3, so I'm going to put the 3 where the 6 and 12 overlap, but it also shares a 2 with 8, and 12 also has a 2. So I'm going to put a 2 in where they all share. And then for 6 and 8, we already talked about the 2 that every 6, 8, and 12 share, but 6 and 8, they don't share any other numbers. And then we look at 8 and 12. Well, 8 shares a 2 with 12 and 6, so we have that 2 still here, but it also shares another 2. So we can put a 2 where 8 and 12 overlap, and what's left? Well, 8 still has another 2 that it doesn't share with anything else. So if we look at these factors, 3 times 2 times 2 times 2, again, we get our prime factors that we just found to get 24. 3 times 2, 6, times 2 times 2, 6 times 2 is 12, times 2, and we get 24. Either method would work, and I guess to better show you how these line up, we have 2 times 3, and 8 has 2 times 2 times 2, and 12 has a 2 times 2 times 3. So what they share in common, we see that they all share these 2's, so that's what this 2 is for. And then the 6 and the 8, they don't share any other numbers. But the 8 and the 12, they do share a set of 2's. So 8 and 12, they share these 2's, which would be this right here. And then we have 6 and 12, they share 3's. We have this 3 and this 3, and that's what this 3 is over here. And that only leaves this other 2 for the 8. And that 2, just by itself, is in the 8 circle for the Venn diagram. So here's just another method of how to identify your prime factors to find the least common multiple.